Welcome back to R for Economics. In this video, we're going to be talking about the random forest estimator. So we're going to bring in our random forest library, R sample, caret, DAG, this is for data, and then Ames housing also is the data. And this is similar to the data used, or identical to the data used in the decision tree video. Just so this is reproducible, I set a seed, bring in my data, and I can get a summary of my data for the spam, yes and no, defining whether it's spam yes or spam no, and then properties of the email that you would have seen in that test for spam data. Here we're going to generate a sample, and we can see that we get a 50-50 split. And now we have random forest, where we're going to, after we generate our training and our test data set, we have random forest, which is going to model yes, no using our training. And we're going to set importance to true. This will be for an option later. Running random forest, we can see that we used number of trees was 500. We could increase that, that's an option. We can change the number of tries with each split. And our error rate is 12.23. So here we get our no's and our yeses, and so that we can compare how well our error rate is looking. We can look at the importance of any of our observations, and we can plot this to see what happens to our error as we increase the number of trees. Now, if we want to run the prediction and get our summary of our prediction, and it tells us how many no's and yeses we get from our predicted. Convert this into binary zeros and ones so that we can get our error rates. And here we can see that we're getting closer to the 90, not quite there, but we're at probably about 87% successfully delineating between spam and not spam. So our misclassification rate is now 12%. If you remember back to the decision tree, we were able to get this down to 13% by using the C tree option, which used a much larger data, much more branches than the R part. And here you can see that we're using the trees in order to get this additional information about how to split these. Now we can go to a regression based. So we split our data, make our training and test, and now we're going to run the random forest function on sale price as a function as the other 80 variables that we have in this data set. So this will take a little time as it runs 500 regression trees, trying numerous different splits. So we will get an output which is can be at times fairly long and involved. And then what we'll be doing is predicting this data and then running a summary. Okay, I'm just going to pause while we wait for this. Oh, it's completed. I'm not going to pause. So now we've got our regression model. It tells us what the call was, how many trees, how many splits tried, and the variance that it's been able to explain is about 89% of the variance. So I can get my prediction, I can get the summary of prediction, I can get the summary of the actual data, and we can see that the mean is getting fairly close. The quartiles and even the median are fairly close together. We can plot our trees and what's happening to our error, and we can see that the error after about 50 or so trees, it gets really low. So increasing the number of trees isn't going to necessarily help because most of our error is stabilized anyway. if we plot these, we can see that now, because this is a random forest and it's trying a whole bunch of different trees for each observation, then averaging them, we can now see that we get a smoother break between the predicted values and the test values. When we were looking at decision trees, we had vertical strikes where the splits came in. And we can also look at the importance of our observations, and we can plot those, and we can see which observations are the most important, as they're the largest, and they have the largest effect on our results. So putting in the ranks, we can see that observation here, 80, being the highest value, is overall quality. So the overall quality of the house leads to the highest price, sale price. If we look at the root mean squared error, we're at 25,000. In the decision trees, the best we could do was 33,000. So the random forest has actually resulted in an improvement in our predictability of sale price. Great, and we'll see you in the next video.